Okay, so in this question, 2b of tutorial 5, we've got the integral of the function x times z between 0 to 0y, x minus y, and x plus y. But we're not told the order of integration. However, there is only one order of integration, and we can have a look at the limits to tell us what it must be. Okay, so the first set of limits depend on x and y. So it must be dz. Okay, so must be the z first. So we've done z. Now the next limits depend on y only, so it must be dx, and by a process of elimination, the constant limits must belong to dy. Okay, so let's perform this integral with those as our limits. So 2 to 0, y to 0. We're integrating xz with respect to z first, so it's x on 2 z squared from z equals x plus y to z equals x minus y dx dy. So that's equal to 2 to 0, y to 0. Now I've got x on 2 times x plus y all squared minus x on 2 times x minus y all squared dx dy. So equal to 2 to 0, y to 0, x on 2 times x plus y all squared is going to give me x squared plus 2x plus y squared. And here I'm going to have minus x on 2, and x minus y squared is x squared minus 2xy plus y squared dx dy. So fortunately this simplifies greatly. Okay, notice I have an x on 2 as a common factor, so it's x squared minus an x squared, which is 0. 2x, well, that should be a y there, 2xy plus y squared. Minus of a minus 2xy will give me 4xy, and the y squared minus y squared will cancel to give me nothing, dx dy. Okay, so let's come down here to finish this off. That's equal to 2 to 0, y to 0, 2's cancel to give me 2, and I get an x squared, so 2x squared y dx dy. So I need to integrate that with respect to x. 2 to 0, so 2 on 3 x cubed times y. That's from x equals y to x equals 0 dy equal to 2 to 0. Sub in x equals y, I have y cubed times y, which is y4, so 2 on 3 y to the 4, and sub in x equals 0, I get 0. So that's equal to 2 on 3 times power 1, 5, so 15, y to the 5, y equals 2, y equals 0, which equals 2 on 15 times 2 to the power of 5 minus 0. Okay, so 2 to the power of 5 is 32 times 2 is 64, so it's equal to 64 on 15, and that cannot be simplified. Okay, there's no number that goes in both 64 and 15. So that will be the solution to our integral. Again, keep in mind that it's very simple as long as you realize all we're doing is subbing in variable limits. So it's just going to be a little bit more complicated algebraically, but the principle is just the same as taking any other triple integral. So the answer was 64 on 15.